So here's a log equation where we have multiple logs. Again, you want to rewrite the log on the left as a single log. Once again, I have the sum of two logs, so I can write that as the log of a product. So on the left, I'm going to have the natural log of x times x minus 1 equals the natural log of x plus 15. Now I can use the fact that log base a of m equals log base a of n implies that m equals n. In other words, I have two expressions equal to each other and I have the same base. Remember, natural log means base e. And so I can just set the arguments equal to each other. X times x minus 1 equals x plus 15. In the expression on the left, I simply distribute. X times x is x squared. X times negative 1 is minus x. And that equals x plus 15. This is going to be a quadratic equation. And so I want to set the equation equal to 0. I'm going to subtract x from both sides and then subtract 15 from both sides. And I get x squared minus 2x minus 15 equals 0. Again, a quadratic equation, you can either use the quadratic formula or you can factor. I'm going to go ahead and factor. This is going to factor to x minus 5 times x plus 3 equals 0. So you're going to get that x equals 5 or x equals negative 3. Notice that negative 3 is not in the domain of these expressions and therefore is excluded. 5 is in the domain, and so the solution set is going to be 5. I do want to mention the fact that just because you get a negative answer here does not mean it's automatically extraneous. You always want to check to make sure that the value is part of the domain of the original expression. Like negative 3 can be in this expression here, so it's potentially a solution. We lose it when we look at these expressions because you can't take the natural log of negative 3 in the real number system.